Fundamentals of Building Construction, Module 2. Structural Systems, Finishes, Services, Safety, and Sustainability. 1. Introduction to Structural Systems. A structural system is essentially the skeleton of a building. It supports the loads imposed on the building, both from its own weight and from external forces like wind, earthquakes, snow, and occupants. We generally categorize building loads into dead loads, the permanent, static weight of the structure and fixed equipment. Live loads, temporary or movable loads such as people, furniture, and vehicles. Environmental loads, forces from wind, snow, earthquakes, or thermal expansion. Types of structural systems. Load-bearing wall systems, walls support floors and roof, common in low-rise masonry buildings. Frame structures, the skeleton of beams and columns carries loads. Walls are non-structural and act as cladding. Shell structures, curved surfaces, domes, vaults, distribute loads efficiently. Tensile structures use cables and membranes under tension, e.g., stadium roofs. Composite systems combine steel, concrete, or timber for optimal performance. The choice depends on building use, height, budget, and local building codes. 2. Floors and floor systems. Floors must support loads safely, provide a level surface, and meet acoustic and thermal requirements. Common floor systems. Reinforced concrete slabs, durable, strong, and fire-resistant. Timber floors, lightweight and easy to install, suited to smaller spans. Steel decks, often used in commercial buildings with steel frames. Suspended floors, supported by beams, columns, or walls, can allow service space underneath. Floor finishes, such as tiles, wood, vinyl, or carpet, are chosen for durability, maintenance, and aesthetics. 3. Roofs and roofing systems. Roofs protect the building from weather and often contribute to insulation and ventilation. Main types. Flat roofs, typically have a slight slope for drainage, can be used as terraces. Pitch roofs shed rainwater and snow efficiently. Curved or shell roofs used for large-span buildings. Roof coverings include tiles, clay, concrete, slate, metal sheets, asphalt shingles, membranes, PVC, EPDM. Roofs must also include provisions for waterproofing, thermal insulation, drainage, gutters, downpipes. 4. Openings, doors and windows. Openings are more than just entry and exit points, they influence lighting, ventilation, security, and aesthetics. Doors can be timber, steel, aluminum, or glass. Designs include hinged, sliding, folding, and revolving. Windows, shapes and materials vary, can be fixed, casement, sliding, or louvered. Glazing technology now offers options like double glazing for insulation, low emissivity coatings for energy efficiency, and laminated glass for safety. 5. Stairs, ramps, and vertical circulation. These elements connect different levels of a building. Stairs must meet safety and ergonomic standards for riser height and tread depth. Materials include concrete, steel, and timber. Ramps essential for accessibility. Require gentle slopes, usually 112 or less, to meet building codes. Lifts and escalators. Used in multi-story buildings for convenience and accessibility. 6. Internal and external finishes. Finishes affect durability, hygiene, comfort, and visual appeal. External finishes. Render or plaster. Cladding, metal, stone, composite panels. Paint or weatherproof coatings. Internal finishes. Plaster or drywall. Paints, wallpapers. Flooring materials. Selection should consider moisture resistance, maintenance, and intended use. 7. Building services overview. A building without services is just an empty shell. Building services make it functional and habitable. Key services include plumbing, water supply, drainage, and sanitation. Electrical systems, lighting, power outlets, emergency backup. Heating, ventilation, and air conditioning, HVAC, comfort control. Fire protection systems, sprinklers, alarms, extinguishers. Communication systems, telephones, internet cabling, security. 8. Electrical installations in buildings. Electrical design must ensure safety from shocks and fire, adequate lighting and power for intended use, compliance with local codes, components, distribution boards, wiring systems, conduits, trunking, switchgear and control panels, protective devices, fuses, circuit breakers. 9. Plumbing and sanitation. An effective plumbing system ensures clean water supply at adequate pressure, efficient drainage to carry away wastewater, prevention of backflow and contamination. Sanitary fixtures include toilets, wash basins, showers, sinks, and urinals. Drainage systems may be separate for foul water and stormwater. 10. Fire safety and building regulations. Fire safety provisions include fire-resistant materials for structural elements, adequate escape routes and exits, fire detection and alarm systems, sprinklers and extinguishers. Building codes also dictate structural integrity, accessibility, energy efficiency, health and safety standards. 11. Sustainable building practices. Modern construction increasingly focuses on sustainability, energy efficiency, insulation, efficient HVAC, LED lighting, water conservation, low-flow fixtures, rainwater harvesting. Material choice, recycled content, locally sourced materials. Waste reduction, prefabrication, recycling construction waste. Green building rating systems, like LEED or BREEAM, provide guidelines and certifications. 12. Construction safety. Safety is non-negotiable in construction. Common hazards. Falls from height. Electrical shocks. Struck by incidents. Manual handling injuries. Preventive measures. Proper PPE, helmets, gloves, harnesses. Site safety training. Equipment inspections. Clear signage and barriers. 13. Quality control and inspection. Regular inspection ensures that work meets design specifications. Materials meet required standards. Defects are identified and corrected early. Quality control is a shared responsibility across all construction teams. 14. Project handover and maintenance. When construction is complete, the project is handed over to the client with as-built drawings, maintenance manuals, warranties. Post-construction maintenance, preventive and corrective, is vital to prolong the life of the building. 15. The future of building construction. Emerging trends include 3D printing of building components, modular construction for speed and waste reduction, smart buildings with IoT integration, net zero energy buildings. The principles remain the same: safe, durable, functional structures, but with ever-evolving technologies and methods.